In chapter 9, we have already studied Newton's first law of motion. Today we have to start Newton's second law of motion. Now, before studying Newton's second law of motion, we must know what is momentum. So, what does this momentum means? To understand this, let us take an example. When a huge mass truck standing and not moving at all, it cannot harm a person standing there. But if the truck is moving even with a slight velocity, then it may harm the person standing over there. And let us take the second example. A small bullet cannot harm you, but when it is moving with a huge velocity, it can harm you. So we can see here that both mass and the velocity are important when we consider momentum. So impact produced by an object depends upon its mass and velocity also. So this is included in the term momentum. It is defined as a product of mass and velocity. It is called the total motion contained in the body. Momentum is the total motion contained in the body, which includes both mass and velocity. It is denoted by P. It is product of V, M and V. So P is equal to mv. M is the mass and V is the velocity. It is a vector quantity and SI unit of momentum is kg meter per second. Now come to this second law of motion. Note down this definition in your copy. Second law of motion states that rate of change of momentum of an object is directly proportional to applied unbalanced force in the direction of force. So note down this in your fair copy. Now come to mathematical formulation of second law of motion. Now we have to prove F is equals to ma. Let us consider an object of mass m. It is moving in a straight line with a velocity, initial velocity u suppose. And after time t with a constant acceleration a, it is moving with a velocity v. It comes to the final velocity v. So now what is the initial momentum? P is equals to mu and the final momentum P is equals to mv. So change in momentum, which is calculated by final momentum minus initial momentum. So change in momentum is mv minus mu. Now rate of change of momentum means change of momentum divided by time. So calculate rate of change of momentum, and that is directly proportional to applied force according to Newton's second law. So change in momentum upon time is directly proportional to, we have taken m common, so v minus u upon t, and we know that v minus u upon t is acceleration a. So F is proportional to ma, where F is the force. So if we consider, so F is equals to kma. K is the proportionality constant. If we choose 1 unit of force and 1 kg of mass with the acceleration of 1 meter per second, then K is 1. So therefore F is equal to ma. Now the definition of 1 Newton force. 1 Newton force is defined as the force which is required to accelerate mass of 1 kg by 1 meter per second square in the direction of applied force. This definition you have to learn, note down in your fair copy. Now Newton's second law can also be defined as F is equal to ma. This says that net force causes acceleration and mass resists it. Means the acceleration is inversely proportional to mass. More the mass, less will be the acceleration. And Force is directly proportional to acceleration. More the force, more will be the acceleration for the same mass. Now comes to application of second law of motion. First application. You can see then while kicking a ball, the ball is moving in the same direction in which you are kicking the ball. And stronger you kick the ball, the further the ball will move. Okay, so that means that force is directly proportional to the acceleration. More the force, more the ball will accelerate. Second application, pushing a cart. You can easily see that in a supermarket when you go, the loaded cart will require more force to accelerate. There are many more applications which we are going to watch in this video.
Study about the applications of Newton's second law of motion. Starting with the first application, cricketer lowers his hand while catching the ball. As you can see here in this figure, a ball is coming towards the cricketer, and while catching the ball, the cricketer lower his hand in the direction of this arrow shown here. Their momentum of fast-moving ball is very lost. If we need to catch the ball, that means we have to get its final velocity 0. That means, in catching the ball, momentum of ball has to be reduced to 0. The force applied on the ball by hands is given by F is equal to mv minus u upon t. By Newton's second law, the force is directly proportional to the rate of change of momentum. If the ball is stopped suddenly, then velocity of ball is reduced to 0 in a very short interval of time. So, if t is very small, then F is going to be too large. And this large force may cause injury or damage. To prevent this, a cricketer lowers his hands while catching the ball. This increases the time taken to stop the ball. And from this expression we can see, if time increases, the force required to stop the ball decreases. Thus, the hands of the player did not get hurt. Seat belts in a car prevents the driver from serious injuries in case of sudden brakes or accidents. The use of seat belts in a car prevent injuries to the passengers in case of an accident or in case of sudden application of brakes. This is because when a car stops suddenly, the belt worn by driver increases the time of fall of passengers forward. Due to this, the rate of change of momentum reduces. Hence the passenger may not get injured due to less force acting on him. So always make sure when you are driving, your seat belts are on. Because if not, your condition can be like this.
There are many more examples given in your book. Just read the chapter and go through it. I think you can understand now. Now, this is one numerical based on F is equals to ma formula. So, read the problem and try to solve all the numericals given in your book also.